Kia ora, year 11, 12 and 13. Here's question 3e from last week's complex numbers paper. So if we take a look at it first, we'll see pretty quickly that it's a discriminant question. We have to prove that the quadratic equation blah 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 will have two distinct real solutions for all real values of k. In other words, no matter what number k is in there, the graph is going to look like this. We've got an x squared here, and we've got no x squareds on the other side. So we've got some kind of up the right way parabola. So for it to have two distinct real solutions, it's got to look like this, or something like this. And that should scream discriminant problem at you. So as usual with a quadratic, we want to have everything on one side equaling 0. So let's start by doing that. So rewriting, we get x squared plus 3kx minus 7x plus k squared minus 3k equals 0. X squared plus 3k minus 7x plus k squared minus 3k lets me quickly identify a, b, and c, the coefficients. So for two distinct real roots, and you have to explain what you're doing, so you need to be writing something like this. We need b squared minus 4ac, strictly greater than 0 for all values of k. So you should already be thinking that what we might end up getting is hopefully a square number, right? Or maybe the sum of two square numbers, and that's exactly what happens with this problem. All right, so let's work out b squared minus 4ac. So that gives me 3k minus 7 squared minus 4. A is 1, so it's k squared minus 3k. If you were sitting the exam last week and you got this question, I'm hoping that you were feeling extremely lucky at this point. I think this question is a really straightforward one that really doesn't test any knowledge beyond level 2 of the curriculum. You've just got to be careful with your coefficients and check your work as you go. So there's my discriminant expression already. Cleaning that up, we get 5k squared minus 30k plus 49. Right, so how are we going to show that that's always positive? Well, there are several different ways to go here, but if you're in my class, you'll know that I love completing the square. So I'm just going to look at those first couple of terms there, and I'm going to take out the common factor of 5. So it's 5 times k squared minus 6k, and just plonk the 49 down out here. We'll deal with that later. And I'm going to complete the square on this bit here. So that gives me 5 times k minus 3 squared, and I've now added in, by mistake, 9 times 5, so that's 45 added in. I have to take it out to keep it even. If you're watching this and you don't know what I'm talking about, I've done some level 2 videos on completing the square that might help you. So that's, if you're watching this video and you're sitting level 3 this year, you really need to have a good grip on completing the square for level 3 algebra. You can kind of get away without it at level 2, but it's just a great skill to have, because it means that on this problem, we've pretty much finished. We've got 5 times a square thing plus 4. Now we have to show why that's always positive. So what we can say here is this is greater than or equal to 0 plus 4, right? And if we want to really spell it out to the marker, what we're going to say is that k minus 3 squared is greater than or equal to 0. And because it's greater than or equal to 4, that means that it is strictly greater than 0. So we're done. But let's just make sure that the person reading this really understands that we really understand. So since b squared minus 4ac is strictly greater than 0 for any value of k, or for all values of k, so for any value of k, the quadratic, or the graph, has two distinct real roots. There you go. I'll do some differentiation paper soon.